Hello, I'm Irene Poza-Casado, a PhD student at the recognized research group Architecture and Energy of the University of Valladolid in Spain. In this video, I'm going to do a short presentation of our conference paper, Airtightness and Energy Impact of the Air Infiltration in Residential Buildings in Spain, presented at the AIBC conference held this year in Ghent. In a context in which the energy demand of buildings must be reduced, one of the factors that have greater impact is the presence of air infiltration. In Spain, this issue has not yet been addressed in depth, and national building regulations do not include the airtightness requirements of the whole building envelope. Therefore, this study aims to assess the energy impact of air infiltration in residential buildings. For this purpose, airtightness results of more than 400 representative cases have been analyzed. Multifamily and single-family dwellings built in several periods and located in 9 regions with different climate characteristics have been analyzed. The assessment of the building airtightness was approached by means of the fan pressurization method according to ISO 9972. Afterwards, the relationship between the air change rate at 50 pascals and under natural conditions was assessed. A linear relationship was considered by means of a correction factor N scaled according to climate, air leakage path size, dwelling height, and shielding, being aware that this is a simplified treatment of a complex reality. The energy load was obtained by means of a simplified model using a classical infiltration calculation obtained as a product of the air infiltration flow, the volumetric air capacity, and the temperature difference between the inside and the outside of the dwelling. Averaged main results sorted by location of the dwellings are shown in the table. The energy impact estimation of the air infiltration was obtained both for the heating and cooling demand. As you can see in the table, air infiltration has a greater impact on the heating demand, especially in cities with a continental climate such as Madrid or Valladolid. Values of up to 19 kilowatts-hour per meter square a year were obtained in the case of Madrid, while in areas with milder climates such as the Canary Islands, the value is limited. In the case of the cooling demand, the energy impact of air infiltration is lower, with maximum values of 3 kilowatts-hour per meter square a year in the case of Sevilla. In other locations with oceanic climates such as A Coruña or Bilbao, it becomes negligible. Of course, a larger sample and a deeper analysis of the data should be considered in order to draw more accurate conclusions, but the obtained results show great potential of energy savings in the country. Air infiltration cannot be ignored anymore in a context where huge efforts are being made to reduce the energy consumption of buildings. If you have further questions, please do not hesitate to read the full paper. Thank you very much.